Hi students, I am Pradipta and in this video session I'll be teaching you about cube and cube roots. So let's start with cubes. First of all, you must be hearing lots and lots of times about the word cube. Actually, it's become very common in our vocabulary, especially while we speak in English with each other. For example, we often mention about cubes of sugar, cubes of ice, and so on. And you must be pondering about what is a cube, and you must be knowing lots of things about that. However, I'm not going into it anymore, but the purpose of this session is to give you an overview about cube and cube roots when it comes to mathematics. In mathematics, let us shift our focus to mathematics and discuss about a cube. Before I proceed, let us discuss that have any one of you tried multiplying any number with itself, like 2 multiplied by 2, or 0.25 multiplied by 0.25, or as for that matter, half with half, or any other positive, negative, real, imaginary number? Choose that and multiply that number with itself. Let's do it once. Like 2 multiplied by 2, or for that matter, half with half. Or if we choose a decimal number, then 0.25 multiplied by 0.25. Any other number, maybe what to say, root 2 square root number, square root 2 into root 2. So try this, and if you can choose any positive and negative number. A negative number, let's take -1 into -1. Any number, right? So whenever we do that, we get a result. So basically, coming back to cubes are such thing which is that if you multiply any number twice with the same number, then we get a cube. For example, 2. If we multiply 2 twice with 2, means first once 2 into 2, then one more time, we get 8. So the cube of 2 is 8. How do we represent that thing? Because every time writing 2 into 2 into 2 is a bit inconvenient, can be a bit inconvenient. So we can write that 2 to the power 3, because there are 3 times 2. So 2 to the power 3, which is 8. Let us proceed then. So as I was saying, that if you consecutively multiply, consecutive means multiplying twice, immediately multiplying twice. If you consecutively multiply any number 2 times with the same number, that means with itself, then the product which you get is a cube of that particular number. For example, the cube of 2 is 2 into 2 into 2, as discussed earlier in this video, or it's 8. Similarly, if you consider half, then it will be half into half into half, or 1 by 8. Again, if we consecutively multiply means immediately multiply twice, not involving any other number in between the process. If we consecutively multiply 0.25 with 0.25 2 times, like let me show it one more time. 0.25 consecutively multiplied 2 times. Once it will be like this, 0.25, one more time, 0.25. This product, what will be coming? This will be the product actually. The product will be the cube of 0.25. The result is this, or the product is this one, and the product is a cube of 0.25. So I hope now I'm clear about how to calculate the cube of any particular number. So if the number is a negative number like -1, then let us multiply it as per the rules of calculating a cube. -1, twice we will multiply -1 with itself. First, -1 into -1, that's once. Again, we'll multiply -1 with that product. So twice we have multiplied -1 with itself, means -1 into -1. We are doing it 2 times. So the result will be, or the product will be -1 itself, because 1 into 1 into 1 is 1. And you must be knowing that, or you must have learned that 2 times if we do a product of a negative number. Once if we do it -1 into -1 once, then the minuses cancels out and it becomes plus. But when again we'll be doing it, again it will be +1 into -1, which will make -1. Let me elaborate once. 2 times multiplication of -1 with itself means -1. Means first time when we do it, -1 into -1, this is actually +1. Again, +1 into -1, which gives us -1. And that's why -1 into -1 into -1, that is the cube of -1, is actually -1 itself. So let's proceed now. So you can easily understand now that whenever we try to find out the cube of any negative number, -1 is a very basic example. If we try to find out the product or the cube of any negative number, then we have to insert a minus sign before the product. Whatever the product may be, we have to insert a minus sign. So let us proceed further. So now here, this is a bit complicated example, that is, as you can see, that the number is a bit complicated. It consists of 2√2, means the number is no doubt a whole number. However, it contains, as you know, 2 positive whole number and another positive whole number, yet it is in inside root. So 2√2 is the entire number. We will calculate the cube root of 2√2. Remember, whenever you see or get such a number, 2√2, what is the relation between this 2 and this √2? It is that of multiplication. Means this number can be considered as 2 into √2. Don't write it like this, it doesn't look good, but for your conception, for your information, I'm saying it is 2√2 means 2 into √2. So while calculating the cube root of while calculating the cube root of 2√2, we will follow the general rule, that is 2√2 multiplying this 2√2 by itself twice into 2√2 again into 2√2. We are multiplying it 2 times, once here, once here. So as discussed earlier, the relation between this 2 and this 2 is that of multiplication. So the entire expression likewise can be rearranged as the relation between these 3 2√2s are also that of a multiplication here, as you can see. So the entire expression can be rewritten as, restructured, reframed as 2 into 2 into 2 into √2 into √2 into √2, which means the product will be 8. 2 into 2 into 2 means 8 into √2 into √2. You must have learned earlier in square root chapter is again 2, and the last √2 we can do nothing about it because we can just multiply it like so. We have to leave it like that. So the ultimate product is 16 √2. So that's how you calculate the cube root of a particular number if it contains a square root or square root part, or any cube root also. If it contains a square root with itself, like 2√2 or 2√3, whatever, you have to do it in this procedure, rearrange it and do it like that. And ultimately there will be a part of under the square root, but a normal whole number part will also be there. So that's how we calculate. Let's proceed then. And before proceeding further, I want to reiterate once more, or repeat once more what I said earlier, that remember that when a number contains a root, then the digits of the number outside the root and inside the root is separated by a multiplication sign. That means 2√2 can be considered as 2 into √2, as discussed earlier. And I'm not elaborating anymore. It may create confusion. So now, so long we have learned also how to calculate cubes and how do we represent cubes while writing mathematics, because every time writing 2 into 2 into 2 or 8 into 8 into 8 like this, or half into half into half, or for that matter 0.25 into 0.25 into 0.25, or -1 into -1 into -1, or 2 root 3 into 2 root 3 into 2 root 3. Every time it's not really convenient. It's inconvenient in most of the cases. So we'll learn about representation of cubes while writing in mathematics. So how do we represent cubes while writing in mathematics? So for example, if you have a number like this, 2, while if you want to, you don't need to write 8. If someone says write 2 cube, 2 cube of cube, it's a cubic root of, I mean not the cubic root, the cubic indices of 2 like this. So you have to write 2, and cube of 2 will be 2 cube, like this you have to write. If someone says write down the cube of -1, don't need to write the result, but the representation will be -1 whole to the power 3. There is a minus sign, so it's better to enclose the -1 within a bracket. Similarly, if the number is 4, we can write 4 cube. If the number is half also, if there's a fraction, then it's better to enclose half within a bracket and then write cube. That means write 3 on it. If we get a number that is a complicated number like this, 2 root 2, then again give a bracket, write 2 root 2 and write 3 like this. Since it's a cube, so write 3 like this. That's how we represent cubes while writing in mathematics. Before proceeding towards cube roots, or rather before proceeding to calculate cube roots, that as written here, the representation of writing the cubes of numbers, as discussed earlier, that's how we present cubes of numbers, 2 cube or 0.25 whole cube, as you can see. And how do you write cube on top of a number? Top of a number, write in small, a bit smaller, the font a bit smaller, and write 3 there. So which represents 2 cube or 0.25 cube, like this. So let's proceed towards cube roots. So in this section, we'll find cube roots now, so long we have concentrated on calculating the cubes of a particular number. Now, cube roots. So to calculate the cube root of any number, we must perform the following steps. Like, let us consider the number 27. So 27, so long we have calculated cubes, be very sure that it will be a cube root, not like the previous procedure we'll follow. We'll follow a different procedure, but it's a root of 27. It's not any product of or any multiple of 27. So it will be a root of 27. So the first step will be factorize 27 and express 27 as a product of its prime factors, because 27 can have lots of factors. Like if we try to list down the factors of 27, it can have 1, it can have 3, it can have 9. Even 27 itself is can be considered as a factor of 27. But only we will consider the prime factors of 27, and we will also exclude 1 also, because multiplying any number by 1 doesn't change the result. So we will exclude 1 also. So what are the prime factors of 27? It is 3 only, if I am not wrong, because 3 is the prime factor of 27, prime factor. So we have expressed 27 as a product of its prime factors, that is 27 equal to 3 into 3 into 3. The next step to calculate the cube root is that the factors which occur thrice should be considered only once. 27 is equal to 3 into 3 into 3. Whenever you are asked to find out the cube root, you have to write like this. The representation should be like this. Not exactly, because it's a computerized document. So the representation should be like this. First of all, cube root is written as this, like this. You give a square root and insert a small 3 to the top left corner. Then the number in question, it's 27 here. So 27 cube root is written like this, the representation. How do you calculate? First, we will find the prime factors of 27 and express 27 as the product of its prime factors. Then the factors which occur thrice should be considered only once. That means 3 is a prime factor and just occurred thrice here. As you can see, 3 is 3 times here. So we will consider it only once. So the cube root of 27 is 3. Similarly, let us find out the cube root of another number. Let us take 8, consider 8 for example. First of all, while considering or writing the cube root of 8, we will represent it as, cube root is written as like this. You give a square root and insert a small 3 to the top left corner of there of the square root, and the number in question is 8, so 8 like it. So the cube root of 8 is written as 8, then you write it like this. And while finding out the cube root of 8, it will be, first of all, as discussed, it will be expressing 8 into its prime factors other than 1. 1 is not a prime anyways, but still expressing 8 in the product of its prime factors. So it will be 8, prime factor of 8 is 2. So 8, if we express it as the product of its prime factor, it's 2 into 2 into 2. It has occurred 3 times, so you will take only once here. So the cube root of 8 is 2. The cube root of 8, I repeat, is 2. Now, there can be another issue while finding or calculating the cube root of a particular number. That is, while factorization, if a factor does not occur thrice, in many cases it may happen, like 16, factorize 16, it is 2 into 2 into 2 into 2 again, 16 factorization. If we express 16 as the product of its prime factors like this, the 2 is occurring 4 times. As you can see, 54. 54, if we factorize, it's 2 into 3 into 3 into 3. So it is 4 times it's occurring. But 3 is occurring 3 times, 2 is occurring only once. So how will we deal the situation while factorization if a factor doesn't occur thrice, or if the occurrence of that factor is not in the multiple of 3? It's either the factor has to occur thrice or 6 times, 9 times, like this, multiples of 3. But what if the factor, while factorization of a particular number in question doesn't occur in the multiples of 3? Then the cube root cannot be performed, and the result has to be expressed just by writing the number as it is, containing the cube root, and with any other sign if required. So let's do such a sum. 54, let's take 54. So here we will calculate the cube root of 54. First, as discussed earlier, we will express 54 in the product of its prime factors. That is, 54 is equal to 2 into 3 into 3 into 3. So we have expressed 54 as the product of its prime factors, 2 into 3 into 3 into 3. Now we will find out the final step, and we'll proceed to the final step towards finding out the cube root of 54. How do we write it? Like this: a square root and then a 3 to the top left corner of the square root. The number in question is 54, and the prime factors are 2, 3, 3, 3. 3 has occurred once, fantastic, and 2 hasn't occurred once. That is, to calculate the cube root of 54, we will write it like this as discussed earlier. I'm really sorry, 3 has occurred thrice and 2 has occurred only once. So by rule, we'll consider 3 only once since it has occurred thrice. The issue is with 2, which has occurred only once. How can we consider it once? Because if it had it considered thrice, had it had 2 appeared thrice in this case, then we could have taken only 1, 2. But here is 3 once because it has occurred thrice, so we have taken 3 once. Fantastic. But 2 here has occurred only once. We can't consider it, or we can't find the cube root of 2 here. So we have to write it, keep 2 as it is. So we have to give the cube root sign, that's square root and a 3 to the top left corner, and write 2 here as it is shown. So the cube root of 54 will only be 3 into cube root of 2. That's the cube root of 54. So that's it for today. Thank you very much.